Hey guys, welcome back. So what we're looking at today is 8.1, go the distance. So let's go ahead and jump right in. So use the number line to find the distance between the given points. The notation AB means the distance between the points A and B. So for the first one, we're looking at AE. So we're going from -4 to +2. So we're going 1, 2, 3, 4. Let's see. That's all wonky. Trying to count that way. So we're going from -4 to +2. So from -4 to 0 is 4, and then another 2, so that would be 6. Now from C to F, we're going from -2 to +2.5. So from -2 to 0 is 2. From 2 to 2.5 is now 4.5. So just use the values given to help you in finding those distances. So describe a way to find distances between 2 points on a number line without counting the spaces. So you can subtract the points and take the absolute value, just like we were doing. So subtract the points and take the absolute value. When we do distance, we always want it to be positive, never negative. All right, for 8, you're finding each of these distances. Remember, for finding AC, you can take and use the Pythagorean theorem after you find both A and B. For 9 and 10, you're just explaining why it's easier and how you would find that distance, or explain how you found the distance. All right, the next section, slope triangles and the distance formula. So triangle ABC is a slope triangle for the line segment AB, where BC is the rise and AC is the run. Notice that the length of segment BC has a corresponding length on the y-axis, and the length of AC has a corresponding length on the x-axis. The slope formula is written as m equals y2 minus y1 over x2 minus x1, where m is the slope. So for A, what does the value of y2 minus y1 tell you? Distance of BC, or the rise for our slope. And so does what does x2 minus x1 tell you? So it tells us the distance of AC, or the run. So now in the previous unit, you found the length of a slanted line segment by drawing the slope triangle and then using the Pythagorean theorem on the two sides of the triangle. In this exercise, try to develop a more efficient method of calculating the length of a line segment by using the meaning of y2 minus y1 and x2 minus x1 combined with the Pythagorean theorem. So what we're looking at here, I'm going to tell you what the distance formula is. The distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're taking the distance that it is between our, so like on this one, from A to C, we're taking that distance, squaring it, and then taking the distance from C to B and squaring it, and then adding them together and taking the square root. So it's using the Pythagorean theorem to find this. So from x value of 2 to an x value of 6, 6 minus 2 squared plus 4 minus 2 squared. Take the square root of that. 6 minus 2 is 4. 4 minus 2 is 2. 4 squared is 16. 2 squared is 4. 16 plus 4 is 20. So this distance for AB is the square root of 20. Now, on 15, they make it a little confusing. They give it all just letters for your points. So all that means is you're plugging them into the distance formula. So D equals the square root of your x values. And it doesn't matter if you do your y values first or your x values because everything's getting added together. So we'll do k minus q squared plus j minus p squared. And that is our distance. If we knew what those values were, we could solve. All right, rectangular coordinates. So more dealing with distances, but this time within rectangles and coordinate grids. So distance is your key word for this lesson. So we want to find HB and BD, and we also want to fill in all the missing coordinates. So if this is an x value of -10, that means at G, it's also -10, and at H, it's also -10. Now, here at E, we're at a y value of -4, so that means F is also down at -4, and D is also at -4. D has an x value of 10, so C also has an x value of 10, and B also has an x value of 10. Now B is up here at a +6, so that means K is at a +6, and H is at a +6. Now, the origin is right here, so that means this is 0, and this is 0, and this is 0, and this is 0. So lots of zeros. So now, between H and B, how far are we going? Well, from -10 to +10, which is going to give us 20. Then for B, from B to D, so from 10 to, or sorry, from 6 to -4, that's going to be 10. So that's what you're looking at doing for 17. Fill in the rest of the coordinates. Make sure you do that, and then find the distances between DB and CF, okay? All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.